First one. Well, actually, it's the 9th one, but first one of the day. Okay. What is the domain of f of x equals x cubed plus 6 all over 3x? Domain there. All real numbers. X cannot equal 0. Do we agree? In our brains, or even on a side note, we're taking our denominator and we're setting it equal to 0 and we're solving it, and so we get 0 there. So x cannot equal 0. Okay? Which means that we have a vertical asymptote of what? Of x equals 0. Okay?
Does it matter if we write all the numbers first, or can we write that second? Does it really matter which order it goes in?
Yes. All real numbers first, then the conditions. Yeah, instead of conditions and then all real numbers. Yep. Okay. Horizontal asymptote here. So this would be from yesterday. So on our cheat sheet, we had 3 possibilities, right? We compare the degrees of the numerator and the denominator. Top bigger, bottom bigger, or the same are our 3 choices, right? In this case, what do we got? Top bigger. So top bigger from our cheat sheet says none. There is no horizontal asymptote on this one. I would agree there. Second one, number 10 here. Domain.
All real numbers, x cannot equal the square root of 6.
Nope. That's a contradicting statement.
And then x just can't equal I plus or minus square root of 6.
Nope. Because how does this gotta start?
Plus or minus.
It starts with all real numbers, right? Okay. So what's wrong with your 2's? I's aren't real numbers, right? So what's the domain here?
No real like plus or minus 6i.
Okay, let's think about it. Okay, let's think about it here now. Okay, if I put a negative number in there, what do I get? I get a positive number, right? Because I'm going to square that negative number,
So it's just all real.
right? And then I'm going to add 6 to it. That's going to be a positive number. Okay? If I put 0 in there, what do I get for a denominator? 6, right? 0 squared plus 6 is 6. If I put a positive number in there, what do I get? Positive number, right? So the smallest that denominator can be is what?
0.
Nope. 6. Okay? So are there any restrictions?
Yeah.
No. Because it can't be 0, right? Restrictions come when the denominator is equal to 0. We just said the smallest that denominator can be is 6. So what's my domain? If there's no restrictions,
All real numbers.
just all real numbers. Which means what is my vertical asymptote? What's my vertical asymptote?
None.
There isn't one. Yep, it's none. Because there's no restrictions. Okay? Top bigger, bottom bigger, same. Same. Okay? So, what's my horizontal asymptote?
Y equals 2.
Y equals 2. What I'd like you to do now is, for all 3 of those, I would like you to find all of the possible asymptotes. Not domain, okay? Just asymptotes. Find me all the asymptotes for all three of those. In number 11 there, do I have a vertical asymptote? Jacob? No, right? Because I square a number, and then I add 1 to it, that's always going to be positive, even if it's 0. Okay? So there's no vertical asymptote there, which means in all of them, is there a vertical asymptote? No, there's no vertical asymptote in all of them because all the denominators are the same. Okay? So in number 11, is there a horizontal asymptote? Is there a horizontal asymptote in the, what is it then? Y equals 0. In number 12, is there a horizontal asymptote? What is it? Y equals 2/3. In number 13, is there a horizontal asymptote? No. So are there any asymptotes in number 13? No. Okay. Questions on those? All right, so let's do the next 3 things here that we need to find. Okay. All right. So step number 3. Okay. Step number 3 is you are going to find the y-intercept. Okay. The y-intercept is where x is equal to 0. So in order to do that, what you do is you find f of 0. Meaning, you are going to plug 0. Oops, that's a bad U. You're going to plug 0 in for x. Okay. At most, you can have 1 y-intercept. That's it. You can only have 1. Because we're talking functions here. If we have 2 y-intercepts, we don't have a function. Because it fails the vertical line test. Okay, so at most we can have 1 y-intercept. When we list out the y-intercept, we are going to list out our y-intercept, or our yint, as I'll refer to it. Vertical asymptotes, remember, I call vas. Horizontal, I call has. Y-intercepts, I call yints. Okay? That's going to be the point 0, comma, some number. Okay. Okay. So we plug in 0 for x in our function. Do the math. That gives me the y value, and then the point point is 0, comma, whatever that number, that value of the function is. Okay? That's all of step 3. Step 3 is an easy step. It's probably the easiest step. Okay? Alright? Step 4. Step 4 says, whoops, missed. Step 4 says we're going to find now the x-intercept. Okay? The x-intercept is where y is equal to 0, or where f of x is equal to 0. Where my function, the value of my function, is 0. It happens when the function crosses the x-axis. That's where my x-intercepts are. My y-intercepts are where my function crosses the y-axis, so my x-intercepts would be where the function crosses the x-axis. Okay. There can be multiple x-intercepts. Okay. There can be multiple ones. A little side note action, a little number sense action, if you will. If I have a fraction a over b, and that is equal to 0, what has to be true? If a divided by b is equal to 0, what has to be true?
Either A or B is 0.
Okay, can b be 0? No, b can't be 0 because I can't divide by 0, right? So then what has to happen? A has to be 0. Okay. In a fraction is only equal to 0 if A is 0. Okay. B can't be 0. It doesn't work out. So we're dealing with fractional functions this entire unit. So how do you think we're going to go about finding our x-intercepts? If I have a fraction and it's equal to 0, the numerator has to be 0. The top value, the a value, has to be 0. So if I have a function, how am I going to find when that function is equal to 0? What do you got? Sounded like you said solve something. Solve what? Set what equal to 0? Okay, so if I set the function equal to 0, what's the first thing that I'm going to do? What's the first thing you're going to do? Get rid of the fraction. How? Multiply by what's on the bottom, right? Okay, so if I multiply what's on the bottom, I would get this, right? What's that whole right side? instead of doing that, what can I just do? Set what? Set the numerator equal to 0. Okay? So we find the x-intercepts by setting the numerator equal to 0. What was that, Gina? It's the same thing as what? No. Horizontal asymptote is degrees. We compare degrees. Set the denominator equal to 0 to find the condition or the restrictions in the domain. Yeah. So no, it's not the same because we're talking one's top, one's bottom. Okay. So the form. I think I used purple for these. Oops. The form then of my x-intercept or my sint, okay, the form of those is going to be some number, comma, 0. Okay. Now, with both y-intercepts and x-intercepts, sometimes we'll have them, sometimes we won't. Sometimes you'll have one of each, sometimes you might have none of each. Okay? If your vertical asymptote is x equals 0 and your horizontal asymptote is y equals 0, you won't have any intercepts whatsoever. Okay? So, but sometimes we might have one of each, sometimes we might have 3 x-intercepts and 1 y-intercept. Okay? It all depends on what the function gives us. Okay? So that's step number 4 now. Okay? So now I want you to skip a lot of space because we're going to skip steps 5 and step 6. Okay? So we're going to go to step 7. And our last step, or it's the 7th step, which is the last step.
How far should we go down the page for funds? I mean, if I'm going on the back side, should I go halfway down, do you think?
Let me see what you got on the front side. Yeah, I would go at least halfway down. At least half of a page.
We have to do step 1.5.
Yep. Yep. But step 1.5 is going to be like one line. Yep. Yep. Okay. So the last step is we're going to find other points using a t-chart. Okay. And that's simply just picking some x values, plugging it into our function, and getting out their corresponding function values. Okay? You've done the t-charts before. Okay? Okay? So I'm not going to spend much time on that one. Okay? But what I am going to spend time on today, the rest of the time today, is we are going to start graphing functions today. Okay? We're going to start graphing these functions. And so what I have for you that I'm passing out right now, actually we'll give you 2 of them right away, is graph paper. And I've enlarged the graph so that you have more space, and I gave you some workspace. So take 2 of each. Oh, I think I'm going to be short. See if I can make if you ever need more, the pink graph paper is what I use for like class notes. It's always up in here. It's in a folder labeled class graphs. Okay? All right? So, let's do this. Graph without using a graphing calculator. Okay? We are not going to use graphing calculators this entire unit. And the reason why is because it's useless to use them. Because you're just going to have to transfer everything over, and your graphing calculators don't show you the asymptotes. But you need to put the asymptotes on your graph. Okay? So it's useless to use a graphing calculator. Okay? I mean, you can to check it, to see what it generally looks like, but you're going to know right away whether or not you're right or not. Okay? So this one says, graph without a calculator, use your steps. So we've got 5 steps now that we have to graphing a calculator, or to graph these things. Then state asymptotal and end behaviors. Okay? You guys have been struggling with the logic behind asymptotal and end behaviors. Now that we're graphing them, you just read your graph. Okay? It'll come right off of your graph. Yeah. Okay? So asymptotal and end behaviors with a graph is a piece of cake. Okay? So, step number 1 says what? Step number 1. Everybody has it. Everybody this should be everybody is shouting out at the exact same time. Step number 1 is set the denominator to 0 because I need to find the domain and the vertical asymptotes. Fantastic. All right. So the first thing I'm going to do is I'm going to say to myself, x plus 1 equals 0, so that gives me x equals -1. Agree? Okay, so what is the domain? All real numbers, but x cannot equal -1. Fantastic. That tells me what for my vertical asymptote? X equals -1 is my vertical asymptote. Now, we're graphing, and we're going to be graphing lines, right? Because our asymptotes are lines, right? So it might be helpful for you to have some kind of a straight edge also. Okay? So I am going to go to -1, and I'm going to put a line. What kind of line? Asymptotes are what kind of lines? They're dashed, dotted, however you want to do it. So when you put your line on there, make sure that it is dashed, dotted, or whatever. Not solid. It can be however you want, Keanu, just not solid. Okay? Step number 2. What was step number 2? Compare the degrees, right? For my ha. Okay? Degree of the top. 1. Degree of the bottom. 1. Those are the same, correct? Okay? So that means I go with coefficients. So my ha is y equals 2. So I can put that. As a dashed line on my graph. Okay. Step number 3 was what? Find the y-intercept. How do I find the y-intercept? Set x equal to 0. So I find f of 0. Well, that's going to be 2 times 0 over 0 plus 1. 2 times 0 is 0. 0 plus 1 is 1. So 0 divided by 1 is 0, right? So my y-intercept is 0, 0. X-intercept. How do I find the x-intercept? Set the numerator equal to 0. So 2x equals 0. So x equals 0. So my x-intercept is 0, 0. It's the same thing. With me so far? Our next step, which actually is the 7th step, and the 7th step is, now I'm going to do t-charts. Now, I'm not going to do one big t-chart. I'm going to do smaller t-charts, and I'm going to do a t-chart for this section right here, and I'm going to do a t-chart for this section right there. Okay. My function again was 2x over x plus 1. Okay. It helps to go near the asymptote, because usually we get nice numbers near the asymptote. So I went 1, usually I go to the next whole number, so that would be -2. If I put -2 into my function, I get 2 times -2 on top, which is -4, and I get -2 plus 1 on the bottom, which is -1. -4 divided by -1 is what? 4. So that function is going to be up 1, 2, 3, and 4. Okay. Let's do -3. 2 times -3 is -6. -3 plus 1 is -2. -6 divided by -2 is 3. So that would be right there. Okay. Then I like to go farther away. So let's go -10. That gives me -20 over -9. -20 divided by -9 is +2 and a little bit more. Okay? So I'm just above 2 out there. Okay? Now I got to go to the other side. I already got 1 point in there. I already got my intercepts. Okay? So then let's go to 1. If I put 1 in there, I get 2 over 2, which is 1. If I put 10 in there, I get 20 over 11, which is just under 2. 2, 4, 6, 8, 10. I think, I don't know if these are the ones, those are the ones. Did they count them? Is it 10 on either side, on both sides? 10? Okay, on yours it's 10. I think on mine it's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, mine's 11. Mine's the goofy one. Okay? Alright? So now I can draw in my function. So my function is going to come through here, and then it's going to make a turn down and go tight to my asymptote. And on this side, my function is going to start here and then make a turn up and be tight to my asymptote. You better not be doing fantasy football. Okay. Okay, good. All right. So now, based off of that picture, does everybody have that picture on their graph? Okay, because I'm going to write, and I don't want to write over all the graph stuff. Actually, no, I will do that. I will write it over all the graph stuff. So what this is saying now is now I need my end behavior and my asymptotal behavior, right? So right here, this is my end behavior for the left side. So that's saying as x is going to negative infinity, my function is going to 2 from above. This one over here is my end behavior for the right side. This is saying as x is going to in positive infinity, my function is going to 2 from below. This one up here is my left side of my asymptote behavior. It's saying as x is approaching negative 1 from the left, my function is going to positive infinity. This one down here is saying as x is approaching negative 1 from the right, my function is going to, there it is, negative infinity. So from the graph, you can get your asymptotal and your end behavior like that. Okay? You don't have to think about it anymore. Okay? Okay? That's kind of like, what's loose on this one? Oh, I can't get to do it anymore. It's crazy talk. All right? You try this one now. Agree with the first step. Vertical asymptotes at 2 and x equals 2 and x equals negative 2. Domain, all real numbers, x cannot equal plus or minus 2. Okay? Graphing wise, there's 2, there's negative 2. Fuck. Alright, fine, we'll just move this then. That works for me too. Okay? Graphing wise looks like that. Okay? Horizontal asymptote, I compare degrees Top is 2, bottom is 2. That's the same. So my horizontal asymptote is y equals negative 2 over 1, which is just y equals negative 2. Agreed. Okay. Y-intercept. X equals 0. Top becomes 0. Bottom becomes negative 4. So that gives me a y-intercept of the origin, which would also be my x-intercept. Yes? Okay. So then I need to do some T-chart action. So my function, oops, missed. My function was negative 2x squared over x squared minus 4. So I'm going to do 3 T-charts, because I've got 3 zones to do those in. Okay? So if I put in negative 3 here, on top I got 9 times negative 2 is negative 18. On the bottom I get 9 minus 4, which is 5. Okay? So that's going to be negative 3.6 to 123.6. So it's going to be somewhere in that range. If I put in negative 10, I get negative 200 over 96, which is a little bit less than negative 2. So it's in there. If I put in negative 1, I get negative 2 over negative 3, which is positive 2/3. If I put in positive 1, I get negative 2 over negative 3, which is there. If I put in positive 3, I get negative 18 over 5. And if I put in 10, I get negative 200 over 96, which is there. Agreed? Color is that one. Spacing is that one. And then that gives me here. Kind of missed a little bit, but that's okay. Here. And there. Right? End behavior. I'll go way down here with it. So my end behavior is, as x is going to infinity, my function is approaching negative 2 from below. As x goes to negative infinity, my function is approaching negative 2 from below. So both on the left and the right side of my graph, my function is approaching -2 from below in both spots. Asymptotal behavior as x is approaching -2 from the left, my function is going to -infinity. That's right here. As x is approaching -2 from the right, my function is going up, so that's going to positive infinity. As x is approaching 2 from the left, my function is going up. I got a parabola in that middle section. Function is going there. It's just a lot of writing. That's all it is. It's not a lot of work because you're reading it right off of the graph. It's just writing it out in the proper format. Okay? So, what I have for you now is I have a two-phased homework. What I would like you to do is I would like you to graph this one at some point in time in the next, before your next class. On there, yep. Okay, on there. And then I have this yellow worksheet, which this yellow worksheet will be due next week Friday. Okay, not tomorrow, next week Friday. But the graph number 3, I want you to do before tomorrow. Tomorrow's quiz is going to have 2 graphs on it. Okay? It's going to be 2 graphs tomorrow, and it's going to be then answering all of the questions. What's the domain? What's the vertical asymptote? What's the horizontal asymptote? What's the intercepts? What's the picture look like? What's the end and asymptotal behavior? Okay? So it's all those tomorrow. Okay?
It's graphing too.
It's graphing too. That's why I want you to do this one tonight. Tomorrow at the beginning of class, I will put up the picture of this one so that you see what it looks like and you can compare, look at it, so that it's an on your own thing. It's up for practice for you, and then we're going to do one graph and then we're going to take the quiz. Okay? Have a good day.